Recording in progress.
Right. Uh, Good evening, students. So hopefully my screen is clear to you. Please confirm that. Please. So please confirm. Yeah. So where could you say me? Where did we stay? Where did we stop last time? So please tell me. Did we finish resistant thermometers? So please tell me where we did we stop last time? Did we do the thermistors? Yeah, we have done thermistor, no? Right. So we have to start thermocouple, isn't it? Yeah, that confirmation come, right? Actually, took some time to exceed number of participants 30, right? So this is the spirit, right? So your badge is 110 or 100, say it is 100. Now, including me, there are 30 number of participants. So we have wait until 4:10, right? So, but usually I do not conduct this kind of lectures, this kind of, there is no any one third of your batch, right? So, but the thing is that in 4 weeks' time, you have a examination, right? You have to conduct your 2-1 examination, right? Therefore, we have to cover these lectures, right? Therefore, I will do, but usually I do not conduct lectures, right? Because the number of participants is very low, right? Right. Anyway, uh, so we have to conduct your examination in uh, 4 weeks time, right? So this is what happened. So we have noticed that. So you are coming in the first year, your attendance is very good, right? Very good. You show a very high motivation, right? Your attendance is good. You are speaking with the lecturers, right? Right. But in the second year, right? In the second year, I don't know what is the reason why. So you are in the negative minded, right? So you are not coming to the lectures, right? So I don't know what happens, right? So, but after the second year, right? When you go to the third year, usually, so you will go with number of repeats, right? And the medical subjects, right? So in the third year, most of the students they are trying to cover at least several subject in the first year and second year, right? In the examination, uh, they are fighting with that, right? There's a war, right? Like that. So, but in the 3-2, right, you are having internship, right? So during the internship, right, you cannot do internship properly because you have to come university time to time to sit for the repeat examination, right? Because uh, in the second year, especially, uh, there might be a problem. They are not coming to the lectures. They are not sitting the exam properly, right? So I don't know what happens, right? Then after 3-2, they know that they know what is happening in the industry, right? What we have learned, right? What we have to learn, what we have yet to learn, right? So they know what happens to in the industry, right? What is going on in industry, what kind of knowledge they are expecting from us, right? Now they are trying to come to the academic program, right? In the fourth year. after the 3-2 in the internships. We have noticed that this is not common for your batch also. In the previous two batch, we have seen that after the internship, most of the students are very motivated. So that is the exposure gained from the internship, right? They know what are their existing knowledge and they know what kind of required knowledge, right? So they have noticed that they have feeling that there's a knowledge gap between existing and required, right? Now they are trying to work, but the problem is that they have not worked properly in the first, second year, third year, right? So they have a lot of repeat medicals, right? Because they are not conducting their academic program well. Right? That's happening, right? So I'm pretty sure that in your batch also situation is same, right? Now you know that it's 100 student batch. Now still 32. I guess that this is same for all the subjects, right? This is same for all the subjects, right? So I'm pretty sure that, right? So you will feel this after the 3-2 might be in the internship, right? Industrial training, right? So this is the gap. So last year, year two, year one to one, you did you completed, I think, relatively good. But we have noticed that your attitude is drastically go down. නේ ඔයාලගේ උනන්දුව සෑහෙන්න දුරකට අපිට 1-1 1-2 එකට සාපේක්ෂව 2-1 එකේ බිඳ වැටලා තියෙන්නේ. right? දැන් 2-2 එකට යනකොට ඕක තවත් වැඩි වෙනවා. මොකද සබ්ජෙක්ට්ස් ටිකක් ඩිෆිකල්ට් වෙනවා. හරි. එතකොට අවසානයේ ඕක රිෆ්ලෙක්ට් වෙන්නේ 3-2 එකේ ඉන්ටර්න් ගියාට පස්සේ. right? ඉන්ටර්න්ෂිප් එක ඉවර කරගන්න විදියක් නැහැ. රිපීට් එක්සෑම් ලියන්න එන්න වෙනවා. හරි. එතකොට ඔන්න 3-2 එක ඉවර වුණාට පස්සේ තමයි ඔයාලා දැනගන්නේ අපි තාම මොකුත් ඉගෙනගෙන නැහැ නේ කියලා. right? නමුත් එතකොට ඔයාලගේ අවුරුදු 3ම ගිහිල්ලා ඉවරයි. තව පුංචි සබ්ජෙක්ට් කීපයක් විතරයි තියෙන්නේ 3-1 එකේ 4-1 එකේ 4-2. right? right? ඒකින්ද ඇත්තටම 1-1 එකේ අපි ස්ටාර්ට් එක ගන්න ඕන. ඒක කන්ටිනියු කරන්න ඕන 2-1 එකේ සහ 2-2. 2-1 and 2-2 very important. And 3-1 as well. right? ඒකෙදි ගන්න එක්ස්පීරියන්ස් එකත් සහ නොලෙජ් එකත් එක්ක ඔයාලට යන්න පුළුවන් 3-2 එකේ ඉන්ටර්න්ෂිප් එක. right? ඔයාලා 1-1 1-2 1-1 සාමාන්‍ය normal you are doing no 1-1 එක ගොඩක් කරනවා. මොකද ආපු අලුත right? young blood they ඔක්කොම ස්පොයිල් වෙන්න ඉස්සෙල්ලා යනවා. දැන් 1-1 1-2 කියන්නේ ස්පොයිල් වෙලා තියෙන්නේ. සියලු දේ දන්නවා ඔයාලා. ඉතින් ලෙක්චර් එන්නේ ලෙක්චරර්ස්ලටත් වඩා දන්නවා. ඒකින්ද එන්නේ නැහැ. right? ඔයගොල්ලන් දන්නවා. දැනගෙන ඉඳලා ඉන්නවා කියලා ඔන්න 3-2 ඉන්ටර්න් ගියාම තමයි තේරෙන්නේ. දන්නේ නැහැ කියලා. we know what happens in the earlier two batches. නේ? හරි. then that is happening in for the 1920 batch. Now they are in 4-2. හරි. ඉතින් අර 1-1 එකේ ගත්ත ඒ ස්ටාර්ට් එක කන්ටිනියු කරන්න බෑ පැනික් වෙලා ඉන්නේ. එතනයි ප්‍රශ්නේ තියෙන්නේ. right? So please think about this. right? Please think about this. right? This is not a joke. right? In 4 weeks time you have a end semester examinations for 4 weeks time. right? So if attendance is like this, so very poor. right? 37. Now it is gradually increasing. Now the time is 4:15. right? 4:50. right? So මම කිව්වේ මේක වෙන දේ. ඒක තමයි ඔයාලා පොඩ්ඩක් හිතලා බලන්න. So you are the elder students, right? ඔයාලා වැඩි හිටියෝ කවුරුත් right? ඔක හැම දෙයක්ම ඉස්කෝලේ වගේ කියලා දෙන්න ඕනේ නෑනේ. Right? ඒකින්ද please think about that. Right? අර 1 එකේ පෙන්නපු motivation එක ඇයි නැත්තේ? Right? what is the problem with that? Right? මොනවා හරි difficulty එකක් තියෙනවද? එහෙම මේ motivation එක පෙන්වන්න බැරි. Right? This is a problem, right? So please think about that. So unfortunately, I couldn't stop today lecture, right? Because we have to conclude few lectures, right? So therefore, I had to conduct, right? කින්ද මට සිද්ධ වෙනවා අද ඒක cancel නොකර කරන්න, right? හරි. So to have we have last in the last session we have done about resistant thermometer, right? So there are several thermometers. Those are operate on resistance technology, right? Variation of resistance and measure the resistance, and we can convert it to the temperature. Measuring temperature by measuring the resistance, right? PRTs, SPRTs, IPRTs, thermostat, thermistors, resistant temperature detectors, RTDs. Those are the sensors built based on this theory, right? So when we go to the industry, uh, in the plant, PRT not available, right? They are using in the laboratory environment, analytical work. But RTD is very common, right, in the industrial plant, right? Right. Today we are going to discuss about another kind of thermometry sensors, right? This is very common in the industry, mostly used temperature sensor that is called thermocouple, right? You have already uh, heard about this, right? This is not the new topic to you, but it's very important to see how it works, right? So very important, right? So thermocouples uh, are operated with the thermoelectric effect. We call it as thermoelectric effect, which is discovered by T.J. Seebeck in 1821, in the beginning of 19th century, right? So therefore, this is called as Seebeck effect also, right? But normally it is thermoelectric effect. This thermoelectric effect is discovered by Seebeck, right? So he observed that when we consider any conductor wire, right, like this, uh, so when we create thermal gradient, right, thermal gradient, temperature difference, right, between two ends, right? So this is 100, this is for a 0. So now we can see temperature difference, gradient. So when we establish this temperature gradient, right, he noticed that voltage difference is established between these two ends, right? So this established voltage is called as thermoelectric voltage, Seebeck voltage in other ways, right? This electromotive force or the voltage difference is called as Seebeck voltage or thermoelectric voltage, right? Right. So this uh, Seebeck voltage V is proportional to the temperature difference, right? When we increase this temperature difference gradient, normally this induced voltage difference increases. Therefore, proportional, right? In addition to that, this induced voltage difference is proportional to depends on the material, right? So we can define Seebeck coefficient for each material. Seebeck coefficient. Seebeck නියතය කියන එක. Seebeck coefficient. right? Coefficient. Seebeck coefficient කියලා අර්ථ දැක්වුවේ we can say that when we create 1 degree gradient, 1 degree temperature difference between two ends, right? The established voltage is known as Seebeck coefficients, right? When we create 1 degree temperature difference between two ends, the induced voltage difference is called as Seebeck coefficient, right? That depends on the material. For example, when we consider platinum, it's a one value. When we consider copper, it is one value like that, right? Depends on the material, right? Therefore, this induced voltage is also depend on the material, right? Right. So this principle, this Seebeck effect, right, can be used to develop another kind of sensors, right? This kind of sensor is called as thermocouple, right? In the thermocouple, you can see here, it consists at least, it consists two metals, dissimilar metals, like that. So red color one, metal A, O1. Second one is blue color one, metal B. You can see this similar metal, Seebeck coefficient is different, right? So at one end, these two wires has joined, welded, right? So other end is open, right? You can see. So when we consider this red color metal one, when we create two different temperature, right? This joint junction at high temperature. So in the other junction at low temperature, right? So you can see this these two ends in the red wire. There is a temperature voltage difference according to the Seebeck effect, right? In similarly, when we consider this blue wire, between since the temperature difference exists between these two ends, there will be a temperature difference between these two ends, delta V2 more generally, right? That means when we consider these two open ends, right, we can see temperature voltage difference, right? When we connect voltmeter between these two ends, we can see some deflections. උත්ක්‍රමණයක් අපිට බලා ගන්න පුළුවන්, right? So this deflection is depend on this temperature, right? So when we heat here, so this deflection changes, right? So this is what happened in the thermocouple. So by measuring this Seebeck voltage difference between these two, we can say what is the actual temperature in this hot junction, right? Normally, this hot junction is called as working junction. Working. Working junction is used to measure the temperature. So working junction has to be insert or touch with the place where the temperature is measured, right? So this is called as this is working end or hot end, right? So other end is called as reference end, reference junction, right? So normally it can be a zero, it can be a room temperature like that, reference, right? Reference end, right? So therefore, in this thermocouple, by measuring the thermal voltage, we can measure the temperature, right? So you can compare with the RTD, OPRTs, right? It is a resistance. Now we are measuring the voltage, right? So when in this diagram, you can see there are two dissimilar metals. One end is hot, other one is cool, right? When we connect voltmeter, we can see a reflection, right? So this induced voltage, right, or Seebeck voltage, we can say that is proportional to the temperature difference, right? Let's say temperature difference. This delta V induced between these two ends over here is proportional to the temperature difference, right? Also, it is proportional to the materials, right? Called alpha constant. It depends on the thermoelectric constant of two metals, right? Therefore, we can say that this delta V is equal to the alpha times delta T, right? So delta T also can be written as alpha times T2 minus T1, right? T2 means hot junction temperature. T1 means cool junction or reference junction uh, temperature, right? So here delta V is measured by the voltmeter, right? So if we know the T1 value or reference junction temperature, right? So by measuring delta V, right, we can measure the T2, right? Suppose that alpha is not because alpha depend on the material, two materials, right? So this is the principle of thermocouple, right? By measuring voltage. Right, this is the governing equation. You can see here alpha time delta T. The temperature of the one junction is fixed at known value, then the temperature of the other junction can be found by measuring the Seebeck voltage. Right? The junction with fixed value of temperature is known as reference junctions, right? Cold junction, reference junction, right? And the other junction is called as measuring junction, right? Working junction, right? Like, right. So then, based on two materials, so now you know that thermocouple sensor, there are two wires, dissimilar wires, right? Based on these two wires, right, thermocouple classified into several types, right? So you can see this is the three types RSP, right? So these are the two wires composition, right? Positive wire having platinum, ruthenium alloys, right? So in the negative wire, there's a platinum and also another alloy can be seen, right? So all these three categories, right, types, you can see platinum is available. Therefore, this kind of these three types are called as noble metal, right? See, they are very expensive, right? And also you can see their maximum operating temperature, right? Measuring temperature is relatively high, right? But they are expensive because platinum is available, right? So another type is called K. K is very common. Sometimes you have seen that in the green color, yellow color, that is grade K. Right? You can see no platinum is available. Only two alloys, nickel chromium and nickel manganese aluminum alloys. Right? You can see uh, two alloys, right? No platinum. It's called chromal and anumal grade K. Right? So this is very common because it can go higher temperature, right? We can replace R and S by this K, right? Because K is not much expensive because platinum is not available there, right? But here RSB having platinum. They are expensive. Right. In addition to that, type N is also there. So we can replace this K by N as well. Temperature, maximum temperature range is closer to the K. And after that, you can see TJE, right? These three types, right? Copper, copper nickel, ferrous copper nickel, and nickel chromium alloy and copper nickel alloy, right? These are the two materials, right? So they are suitable for measuring low temperatures, right? So nowadays, when we consider industry, right, they are using K, right, for the low temperature and high temperature application as well. But K is more ideal for the high temperature one. K is not for the low temperature, but it can measure, but error is high. For the low temperature, there are specific type of thermocouples, right, sensors. T is very suitable for low temperature. You can say 370. After that, type J is suitable, right? So you have uh, did one practical sometime, right? Sometime you haven't done, right? Uh, you can see the our laboratory. You can see some thermocouples, right? Uh, uh, Thermocouples are available, which is brown color. It is basically type G, right? So these are the various types of thermocouples, right? Types. When two material changes, their type is and properties and maximum measuring temperatures also uh, get vary, right? So these are called as letter designated thermocouple. තේමකප්පල් අපිට letter එකකින් designate කරන්න identify කරන්න. These are called letter designated thermocouple. Right? Right. Right. So these are all these are called noble, sorry, base metal. Right. These three are called noble metal. RSP noble metal. These others are called base metal. Right. You can see different thermocouple give different voltage at constant one temperature. You can see when you consider Fahrenheit, 1000 Fahrenheit, you can see different thermocouples give different uh, millivolts, right? Seebeck voltage, right? So the thing is that uh, for the low temperatures, type TJE are suitable, right? After that, KN suitable. At very high temperatures, R's SP are very suitable, right? Therefore, we have to select uh, best type of the sensor based on our requirement, right? Right. So therefore, uh, thermocouple measure voltage difference between, voltage difference, right? So in order to convert this voltage difference to the temperature, it need uh, load measuring junction or sorry reference junction temperature, right? So we have learned that the governing equation, right? Delta V equal alpha times constant depending on two materials. T1 means T measuring T reference junction, right? So in order to measure this TM measuring junction temperature, right? We need to know this TR reference junction temperature, right? So based on the value of this TR, we are having two measuring modes, right? Two measuring modes. One mode is called as uh, external mode, right? So in the external mode, right? The external mode, always this reference junction is in zero, right? ඒක ice වල ඇතුලේ තමයි තියෙන්නේ. Reference junction is zero, right? So that is one type, external mode at zero, right? So if it is not zero, that is called internal, right? Internal mode. Internal, right? Right. So therefore, based on the temperature of reference junction, we are having two measuring modes, external measuring modes and internal measuring modes, right? Right. So we will consider that for the real thermocouple, right? So we are selecting here uh, type T1, right? Type T, we have know that what are the two materials? It is copper and type T, copper and copper nickel. We call it as constant term, right? It's a alloy, right? You can see these are the two wires. This is one wire is joined at working end, and this is the second wire, right? So to measure this voltage difference between these two ends, right? We have to connect it with voltmeter, right? So, but thing is that with the connection of voltmeter of these two ends, it introduce two more junctions, right? දැන් මෙතෙන් තිබුණේ එක junction එකක් විතරයි, right? එතකොට මේ දෙක අතර voltage difference එක depend වෙනවා මෙතන temperature එක සහ මෙතන temperature එක මත, right? There are two one junction, right? J1 measuring junction. But with the connection of this voltmeter by these wires, it will give two more junction. This is one because inside the voltmeter, it's a copper wire, right? Copper to copper. Here, copper to constant, right? There are two more junction established, introduced, right? So this is first major one, J1. So this is the second one. This is the third one, right? So, but when we consider this third one, right? These are the three junctions. This is the main junction at working end, the second one, and this is third. When we consider this third junction, J3, you can see that both wires are copper, right? Two sides are equal. Therefore, no voltage difference induced between these two wires, right? Therefore, V3 is zero, right? But J1 is different, right? But when we consider J2 once again, you can see this wire is copper. This wire is constant. So therefore, definitely V2 is non-zero. Therefore, total resultant voltage difference between these two ends, right? V is equal V1 minus V2 because V3 is zero now, right? So V1 minus can be written as V1 minus V2 can be written as alpha time T1 minus T2, right? So this is the equation, right? So that is what we have obtained that T1 minus T2. So based on the value of T2, we are having two measuring modes, external and internal. In the external mode, T2 always at zero. The external one, right? T2 0. So therefore, in the external one, T2 is 0. Therefore, it can be simplified as V equal alpha T1, right? So by measuring this voltage, right, we can measure T1. T1 means junction J1 temperature, right? T1 temperature, right? So this is called external zero junction compensation, right? In the external reference junction compensation, T2 is zero always, like that. So we have to immerse that reference junction at zero, like this, right? So here you can see this external junction here, right, is inside the junction. Right? You can see. So this is the working end, right? So this reference junction in both wires is inserted into the zero ice bar, right? Then we can connect these two wires with the voltmeter by the copper wires, right? So these two are the copper wires, right? So you can see both reference junction is inside the zero ice, right? So this kind of compensation is called as external. Externally, we are providing ice, right? Right. So we can directly measure the temperature of the working junction for junction, right? At cold junction or reference junction, always at zero, right? Then we can place this hot junction at various temperatures, right? අපිට එක එක temperatures වල මේක තියන්න. 0, 10, 5, 15, 20, 100 වගේ. ඒ හැම එකකදීම we can measure voltage. හරි. ඒ හැම temperature එක මේ reference junction එක 0 වල තියලා අපිට මේ voltage value එක මනින්න පුළුවන්. Right? Then we can generate table, right? So this is that kind of table for the type K, right? So these two axes are temperature, right? So in the middle values are the voltage, seebeck voltage values, right? අපිට ඕනම temperature එක කියලා අපිට value එකක් ගන්න පුළුවන් voltage, right? ඒ විදිහට කරලා we can build this kind of table, right? These kind of tables are called as thermocouple table, right? So this is for the type K for the negative one, negative below zero. So when we go to the next one, this is for type J for the onward zero. හරි. peak temperatures වල තියලා අපිට voltage value එක මනින්න පුළුවන්. ඊට පස්සේ we can generate this kind of table, right? So what is the purpose of generating this table? Later on we can measure any unknown temperature. For example, there's a hot temperature, so we need to find the hot temperature. So what we have to do is we have to insert our thermocouple measuring head to the that place, and we can measure the voltage, right? Like this. If we measure voltage like 5.378, right? By using this table, we can say actual temperature of the measuring junction. If it is 5.378 means this point, right? We can go back to the temperature 100, 100.1, 101, 102. Therefore, we can say that the temperature at that point is 102. Similarly, if we measure voltage like 10.446. So what is the relevant temperature? 190, 192, 193, 194, like that. So using this temperature tables, right? Using this thermocouple table, we can say we can convert our measured voltage value to the uh, uh, temperature, right? So that is why we are generating this kind of table. So each and every thermocouple type, we have separate table, right? So these values is different for the different thermocouple type, right? These induced voltage values are different, right? Right. So that is, you can see that in each of these table, we can see that reference junction is at zero, right? Cool junction is at the zero ice bar, right? Right. So that is called external one, external reference junction compensation. But you know that sometime uh, we can measure the temperature by using a multimeter as well, right? Like this. So we can measure temperature by just inserting this thermocouple wire into the multimeter. But in this method, we are not using any ice, right? So how do we measure it, right? What happening to the reference junction? This kind of one. So here we are using internal coil junction compensation, right? Internal. In the internal method, we just insert two wires into the meter, voltmeter, and measure the uh, voltage, right? Right. So no need any zero reference junction, no ice bar, right? What's happening here when we connect these two wires to the meter, it connect with the slot, right? This is the slot in the meter, so it connect with the thermocouple wire connector or wire, right? So close to the this slot, we can see that thermocouple sensor, sorry, the RTD, oh, sorry, thermistor sensor, right? Can be a thermistor, right? So now you can see that this end, that means reference end, second end, right, is at room temperature, right? That connect with the slot in the meter, right? So this end now it is not at the zero. Now it is at the room temperature, right? To measure this temperature at this juncture, this end, there is a thermistor sensor is available. You can see this is the circuit board. So these two are the slots, two slots where these two wires are connected. So close to the these two terminals, there is a RTD, or sorry, thermistor, right? So it measure temperature near to this, right? So all these parts are inside the junction box, right? You can see inside the junction box. These are the measuring end. These are the reference end, right? Now referencing end is inside the box in the meter. To measure the temperature inside this box, there is a thermistor is available, right? You can see thermistor here, right? It measure uh, actual temperature inside the meter, right? Inside the junction box. Now it is not at the zero, right? It is normally it is at room temperature, right? So then similarly we can measure the voltage, right? We can measure the voltage, right? Right. Right. We can measure the voltage and we can go to the uh, thermocouple table, right? Here, like that. We can go to the thermocouple table if we measure that voltage, and we can measure the corresponding temperature. But the problem is that, right, we cannot get temperature value by using these tables in this internal method, because this internal method, the reference junction is not at the zero. හරි. දැන් අපි මේ දෙවෙනි අවස්ථාවේදී reference junction එක තියෙන්නේ junction box එක ඇතුලේ. They are not at the zero. හරි. Therefore, we cannot use this table straight away. කෙලින්ම අපිට table එකට ගිහිල්ලා temperature එක මැනගන්න බෑ. Because අපු මැනපු voltage එක බිඳුවට සාපේක්ෂව නෙවෙයි. Therefore, we have to make small correction for that. Right? So this is the value we are measuring. Right? It measures voltage with respective to the temperature at the junction box. Most probably, it is at the room temperature. Right? Therefore, this need to be converted with reference to the zero. අපි මේක බිඳුවට සාපේක්ෂව හදාගන්න. Right? How do we measure respective convert to the zero reference? We have to add correction factor. Right? To know this correction factor, we need actual temperature inside the box, inside the meter, right close to these two terminals. To measure that, thermistor is there. This thermistor measure temperature. For example, it measures as a 27 Celsius, right? Then what we can do is we can go to the thermocouple table, right? Also 37. So we can get the relevant uh, voltage value. 37, sorry, 27, 20, 21, 22, 23, 24, 25, 26, 27. So that is the value 1.381. Therefore, we have to add 1.381, right? We have to add 1.381, right? To the value we are taken by the meter, right? Then these two addition of these two values, it convert to the this value with reference to the zero. දැන් තමයි අර බිඳුවට සාපේක්ෂව value එකට ආවේ. Then we can directly go to the table, right? Then we can directly go to the table and we can measure uh, corresponding temperature. For example, if we get the value like that, uh, for example, here we obtain value, measured value is something like that 4.381 like this, for example, randomly. So we have to add these two values. What's the value? 2, 16, 7, 5, 5.762. Then we can go to the couple table. 5.762, 5.762. So 5.762, 5.759. So this is the closest value, right? So what is the actual value? Temperature value is 100, 109, right? So this is the value. Then that means temperature is 109. So that is the temperature at the hot junction, right? So 109. Right. Like that, right? Therefore, this external method is so easy, right? But we have to make this correction, right? So therefore, internal method, no need eyes, right? It is just connect and measure, but needs this conversion, right? But this kind of machines, they know about the tables and they do this calculation, right? In the processor, they process, right? They measure the voltage and measure the temperature, reference junction, and they find the correction factor and they add that correction factor to the measured voltage. They obtain voltage refers to the zero and they compare with the table and give the final temperature value. It's programmed one, right? Everything is done by the microprocessor, right? So, but I have explained here what is happening. So, in order to give this temperature, reference junction is very important, right? In the external one, reference junction is at zero. But in the internal method, this reference junction at room temperature close. Select some meters, this kind of meters, multimeters, and this kind of portable one, they support for internal method only, right? But some sophisticated high-end devices, thermometer, they support both type, external and internal, right? In the measuring, uh, in the measurement, we have to select, right? What is the compensation mode, internal or external, right? We have to select it. We have to go to the menu and we have to select it, right? Right. So therefore, this measuring, this cool junction compensation or reference junction compensation with thermocouples is very important, right? Very important, right? So, so what's the difference between these two? මොකක්ද මේ දෙක අතර තියෙන වෙනස? මොකක්ද වඩාත්ම පහසු? External internal. අපි internal ගත්තොත් ගොඩක්ම පහසුයි. right? අපි මොකද්ද කවුරු හරි ඇහුවොත් මේ දෙකෙන් වඩාත් නිවැරදි මොකද්ද කියලා we can say external mode is very accurate because the temperature of reference junction is fixed. ඒක බිඳුවේම තමයි තියෙන්නේ. right? cool junction එක බිඳුවේ. ඒක වෙනස් වෙන්නේ නැහැ. Therefore, measured voltage is constant. But thing is that in the internal method, the reference junction, cool junction is at the junction box. So that temperature changes with the ambient temperature. Ambient එකේ වෙනස temperature එක වෙනස් වෙන්න මේ circuit එක board එකේ තියෙන temperature එක වෙනස් වෙනවා. Therefore, this internal method, the measured temperature is not much accurate as external method. හරි? Accuracy wise, external is the best one. Right. Right. So, each and every type of thermocouples, right? There are different specifications coming, right? So you can see these are the different types, right? Each type having maximum error. You can see we have learned about tolerance, ne? Right? Extreme values of errors, right? You can see different thermocouples give different uh, errors, maximum errors, right? You can see. So when we consider this RSB, the errors, percentage error is a little bit low than the other one, right? You can see. And also, how do you identify these sensors? With thermocouple sensor එකක් අඳුරගන්නේ කොහොමද? So we can identify by its. Right? What is the color? 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 Right? color, right? Usually, these colors couldn't by standard. There are two standard, ANSI code, American National Standard Institution code, right? According to that one, red K are the yellow. You can see yellow one, right? These two are internal two wires, right? So this is sheet with the yellow color, right? But there's another one, IEC, International Electro Technical Commission. So that is according to that standard, red K is always green color, right? Type J, both standard black color, right? Type T, according to NSI, it's a blue color. Uh, IC, according to IC, brown color, like that, right? So we can identify uh, type by usually its color, right? Manufacturer has to give color, and also they has to give what is the standard they are using, whether it is IEC or NSI code, right? So therefore, if you are purchasing this kind of sensors, is very important to identify the type, right? So for example, uh, the type is based on our requirement. For example, we need to measure more than 1,000, right? So therefore, you have to go for the at least K O N, right? So another one, you have to measure extremely low temperature, 100, So you can select type T and G. K can, but it is not correct at low temperatures, right? Like that. So you have to select best type based on their your requirement, right? So therefore, you have to identify sensors by their color codes, right? Right. So what are the advantage of and disadvantage of thermocouples? We can compare it with the previous one, resistive thermometers. කොහොමද අපි compare කරන්නේ? Hmm? So first one is versatile, right? We can use it for many applications, versatile, right? Manufactured locally by welding. So we can prepare these thermocouples by welding. We can locally prepare, right? If we have thermocouple wires, we can solder one end. By soldering one end, we can make thermocouple wires, right? They are very easy. No external current and no external precaution needed, right? Also, they are very robust. හරි දැන් අර PRTs වල තිබුණේ PRT wire එකක් තිබුණේ. They are very fine coil. So that coil is easily can be damaged by the mechanical shocks or thermal shocks. Right? Therefore, PRTs has to be used with great attention, right? But that is not needed for thermocouples, right? Thermocouples are more rugged, right? Very robust, and they are very versatile, right? And also very cheap, right? Only RSB are expensive because of platinum. Others are very expensive, cheaper. And also temperature range is wide variety of temperature range. And also we can get this thermocouple in different shapes. You can see here, right? So in this kind of thermocouples is more common in the plants, right? It's a one type, right? This is another flexible one, right? Flexible wire as a flexible type, right? So it is independent of shapes, right? We can have different uh, thermocouples with different shapes, right? So you can see here, this is the tip working end, right? We can make this by just soldering, right? Right. Uh, these are the disadvantage: non-stability, non-linearity, and less accurate. Basically, accuracy of this thermocouple is little bit lesser than uh, it is lesser than PRTs, right? Right. So that's all about this thermocouples, right? So please, is it clear? Is it clear? So now there are two types, right? Resistance thermometry and voltage thermocouples. So is it clear with these two principles? Sometime when you go to the industry, right? Uh, you may come across these kind of devices, right? Thermocouples, right? No problem with this principles, right? Everything is clear, right? Silent means yes, sir. Right. Thank you. Then we can go to the next type of thermometers. Right. Right. So this is a next type of thermometers, right? We know that this is very common that we call it as simply it is called as glass thermometer. So sorry. So is it clear? This screen. Is it clear this screen? Can you see this slide? Right. I guess that you can see my screen, right? So this is the next type, liquid in glass, right? So simply we call it as glass thermometers. अभी इधर thermometers के लगे आने or not, right? So the principle is different, right? Can you say its principle? So what is the parameter we use to measure the temperature? Hmm? So in the previous one in the resistance one, we measure the resistance. In the thermocouple case, we measure the voltage. So what is the parameter here we are using? So it is the expansion of liquids, right? You know that liquids expands with temperature, right? We are using that property to measure the temperature, right? So here, in the manufacturer manufacturing of this thermometers, so mercury is the best liquids, right, to use. Right here, this is the liquid, right? So in the past, uh, mercury are best option, right? Best candidate to use with use as the uh, material, right? Liquid. But thing is that mercury is toxic now, right? So therefore, the use of mercury is minimized. Therefore, nowadays we are not using mercury for this making this LIG. Instead of this, we are using spirits, alcohol, right? Spirit. But most suitable one is this mercury, right? According to its properties, right? They are very density is very high, right? The viscosity is very high. It's very ideal than the spirits, right? But mercury is has some health issues, right? Therefore, we are not using mercury. We have minimized use of mercury. Therefore, nowadays, uh, thermometer LIGs are coming with spirits, right? So in the practical, you are using one LIG, so it is spirit type, right? No mercury is available there, right? So inside this LIG, right, liquid in glass thermometer, it is made by glass, right? So this part is called stem, right? Here is stem. It's a glass, right? So inside at the center, there's a capillary tube, right? So this capillary tube is connected with the bulb, right? So the purpose of bulb to contain the liquid, right? Right. So in the stem, yeah, in this capillary tube, you can see there are two chambers are available, right? At this stem, you can see it's a stem. It's a called contraction chamber. There is a one requirement, right? So there's another chamber available at the top. It's called expansion chamber, right? So the reason why this contraction chamber is there, you know that normally it measures the expansion of the liquid, right? But at very high temperatures, right? So this liquid column will go up, right? Therefore, height or length of the thermometer will be very high, right? It is might be not practical, right? Therefore, in order to short this height of the thermometer, so by providing this kind of chamber, it gives some space to expand. හරි ඒක අර ලික්විඩ් එකකට දෙනවා අමතර පරිමාව. හරි ඒ වගේ චේම්බර් එකක් හදලා නැත්නම් මේක උස වැඩි වෙනවා. Right? So that is the purpose in order to shorten this step. Right? So what is this? What is the this idea of this expansion chamber? So you know that normally this capillary tube is closed one, right? So liquid is after the liquid it fill, it will be vacuum and filled with some inert gas. What do you mean by inert gas? Because සිංහලක නිෂ්ක්‍රීය වායු. මොනවද නිෂ්ක්‍රීය වායු? උදාහරණයක් කියන්න පුළුවන්. Inert gas කියලා කියන්නේ. Nitrogen is not the inert. Argon, very good. Argon, neon, like that, right? Those are inert gas, right? So normally this area above this liquid column, the inert gas is filled. Why? If there is no empty, it's a vacuum in this area. What happened that this column will be break, right? For some time when we go up, after cool down, it will be retracted to the bulb. But sometime these columns will be remaining at the middle of the capillary tube. නේ සමහරක් වෙලාවට මේ කොලම් බ්‍රේක් එක කැඩෙන්න පුළුවන් නේ එතකොට උඩට ගිහිල්ලා ආපහු යටට එනකොට ඒක යටට එන්නේ නැහැ. ටිකක් එනවා ටිකක් කැඩිලා තියෙනවා මත. So column break happens, right? So in order to avoid this problem, we have to fill this area with the gas, inert gas, like argon, helium, like that, right? Right. So this cause another problem. මේ අපි මේ පුරෝපෝ එක හින්දාම තව ප්‍රශ්නයක් ඇති වෙනවා. මොකද්ද? So when we measuring this temperature, higher temperature by this LIG, what happens that the temperature of the liquid increases. Therefore, it will expand, right? Therefore, this column will go up, right? මේක උඩට යන්න යන්න මොකද වෙන්නේ? අර තියෙන නිදර් ගෑස් එකේ පරිමාව එන්නම අඩු වෙනවා. When volume decreases, what happens to the pressure? Pressure building up. And also temperature is also high. Pressure is very high. What happens? Sometimes there is a risk to blast this capillary tube, right? Therefore, in order to reduce that pressure, it this gives extra volume. මේක දෙනවා පොඩි වොලියුම් එකක්. හරි? extra volume එකක් දෙන්න. ඒක දුන්නම ඒක pressure එක අඩු කරනවා. Right? So to avoid blast, right? To protect the thermometer, there is expansion chamber, right? දැන් මේවා හැම එකකම තියෙන අදහසක්, right? එහෙම නැතුව මේ ලස්සනට මේවා හදලා නැහැ. හරි? Right? Right. So these are the main parts, right? Scale is available along the stem, right? So what is this line? මේ line එකක් ගැන ඔයාලා දන්නවද? thermometer එක line එක මොකක්ද දන්නවද ඔයාලා? ඔයාලා practical එක කරපු අය දැක්කේ නැද්ද line එකක් එහෙම ගහලා තියෙනවා කියලා? What does it mean? කවුරු හරි කෙනෙක් දන්නවද ඒක අදහස? guess කරන්නකෝ බලන්න. So this is called immersion line, right? Temperature line. Called immersion line. Immersion line means we have to insert this thermometer up to this line in order to correct reading. In order to get correct reading, we have to immerse this thermometer up to this line, right? Otherwise, its reading is incorrect, right? right? Incorrect, right? So based on its immersion depth, right? In an immersion line, LIGs are three types, right? Partial immersion, right? In the partial immersion, like the previous one, right? So you can see line is there in those steps. So we have to partially immerse this thermometer up to this line. Normally it's 76 millimeter, right? So this line is given by the manufacturer, or sometime manufacturer has given immersion depth here, like 76 millimeter like that. So we have to immerse this up to this line. Otherwise, its reading is not accurate. It's called partial immersion, right? Second type is total one. In the total immersion one, we have to immerse the thermometer so that this liquid column is totally inside the sample. huh? දැන් previous one එකේ දැන් මීට උඩට මේක යන්න පුළුවන් mercury column එක. හරි? මේකට පුළුවන් උඩට මේකෙන්. But in this total one මේ mercury column එක ගිහිල්ලා නවතින්නේ කොතෙන්ටද? එතෙන්ට දක්වා මේක ගිල්ලන්න. Right? In order to give correct reading. So we have to give the thermometer up to the top of the mercury level. Right? So that is a different. Right? So how do we identify this? The type. Usually manufacturer has to give. Right? If it is total, good manufacturer has to give total immersion. Right? Like that. Third type is called as complete. Complete में thermometer के inside. Right? ඒ කියන්නේ මේ විදිහට. අපි තුමේ බීකර් එක ඇතුලේ තියෙන වතුරේ උෂ්ණත්වය බලමු. Right? Partial immersion එකේ we have to immerse up to the line. Mercury column can be above. Right? Total one, mercury column completely inside. Right? Total immersion, fully complete immersion one, totally this thermometer inside the sun. Right? So three different types, three different scenarios, three different types, right? Three different ways, right? Right. So with this LIGs, there are two problems, right? මේ glass thermometers එක problems දෙකක් තියෙනවා සාමාන්‍යයෙන්, right? What are those problems? One is called as secular change, right? Secular change කියන්නේ දැන් අපි this is made by the glass, right? විදුරු වලින් හදලා තියෙන්නේ, right? So when during the manufacturing time, right, some strains are taken place. හරි? සමහර වෙලාවට මේ මැටීරියල් එක ඇතුළට සමහර strains ගිහිල්ලා තියෙනවා. Mechanical strains වෙන්න පුළුවන්. Manufacturing strains වෙන්න පුළුවන්. නැත්නම් ඒ වගේ දේවල්. Right? When what happens that when it is using, අපි මේක use කරනකොට what happens that it will be heated නේ. වීදුරු රත් වෙනවා. රත් වෙනකොට මොකද වෙන්නේ? අර තිබිච්ච strains ටික heat treatments එන විදිහට ඒවා relieve වෙනවා. They will leave. Right? So what happens then? The size of the bulb changes. Right? Normally, size of the bulb will be reduced, contraction. Right? What do you know in name? Right? Then what happens that this its calibration changes, right? අපි ගන්නකොට වගේ නෙමෙයි ටික කාලයක් පාවිච්චි කරනකොට ඒක 0 එක පෙන්වන්නේ නැහැ හරියට. Right? Because bulb is contract. ඒක සංකෝචනය වෙලා. Right? Due to the leaving strains, right? When it is used. We can easily detect that secular change by checking the ice point, right? ice එක දාලා එක බලන්න පුළුවන් ice point එක හරියට 0 තියෙනවද කියලා. 0 එක නැතේ කියන්නේ ඒක secular change තිබිලා ඒව ගිහිල්ලා, right? That is one problem. Second one is that temporary repression to 0, right? ඒක මොකක්ද? ඒක වෙන එකක්. දැන් ග්ලාස් කියන්නේ එක අපි දැන් රත් කරනකොට ග්ලාස් එකත් එක්ස්පෑන්ඩ් වෙනවා නේ. අපි මේක වැඩි උෂ්ණත්වයට ගිල්ලනකොට ග්ලාස් එකත් රත් වෙනවා. right? රත් වුණාම මොකද? ඒ ග්ලාස් එකත් expand. It will expands. Right? Right? But when we cool, right? When we get it out from the sample, it will be cooled. Right? So, but the thing is that uh, the glass is not cooled quickly. Right? Right? It takes some time, 1 day or 2 day. It will not come back to its normal volume. දැන් අරක normal volume එකේ තිබිලා අපි sample එකට දැම්මම මේක රත් වෙනවා. රත් වුණාම ඒක ලොකු වෙනවා, expand වෙනවා. නමුත් අපි sample එකකින් අරගෙන තිබ්බ කියලා එකපාරට ඒක volume එකට එන්නේ නැහැ. It takes some time. Sometime 1 day, 2 day like that. Right? Right? Therefore, it needs some proper conditioning after the measuring. Right? අපි දවස් දෙකක් එක තියන්න. Right? Temporary there is a 0 point is can be drifted. Right? අර ලොකු වෙලා තියෙනකොට temporary 0 එක වෙනස් වෙන්න ඉඩ තියෙනවා. That is why called temporary repression to 0. ඒක temporary effect එකක්. Right? Once it keep it conditioned for 1 day or 2 day, this problem's over. Right? It is called temporary repression to 0. Right? These two problems can affect LIGs. Right? Therefore, when you use these LIGs, be careful. Right? You have to select best high, and we have to say we have to use it proper way, and we have to careful with these effects, right. So what's time now, right? So next type is bimetal thermometer, right? We will continue it next week, right? Or probably you will come to the university in person by next week, right? Hopefully we wish you can be able to come to the university in person next time by next time, right. So please text your index number in the chat box. Sometime attendance, this time attendance will see, right, for the examinations, right. Therefore please text your index number to the chat box. There are 35 students. There should be a 35 index numbers, right? So after putting your index number into chatbot, you can leave, right? Thank you very much for joining. We will meet next week. Right?
Recording